Hello and welcome to yet another review session for your final exam in Calculus 3208, brought to you by CDLI. And today we're going to look at derivatives of expressions with exponential and logarithmic functions. So lots of different things going to happen here. We're going to combine all the things we know about derivatives of exponentials and all the things we know about derivatives of logs, and we're going to put them all together and differentiate some really big, ugly functions. Let's see what we can come up with. Derivatives with exponentials and logs. So we'll talk about this just quickly. We're going to apply all of our differentiation rules to these expressions, and we're going to practice. Here we go. Let's make sure you got these in your brain. These are the derivatives of exponential and logarithmic functions. So we've seen these before. Hang on to them. Keep them in your back pocket. You need to know them. E to the x gives you e to the x when you differentiate. A to the power of x is a to the power of x ln a. Ln of x is just 1 over x. And log base a of x gives you 1 over x ln a. Let's go. First example. Differentiate f of x equals log base 2 of, let's throw some trig in there, sine of x plus cosine x. Alrighty, let's try it. So f prime is going to be the derivative of log base 2 of stuff is 1 over the stuff, which is sine x cos x, or sine x plus cos x, sorry, multiplied by the natural log of the base of the logarithm, which was 2. Then I also have to multiply by the derivative of the argument here, sine x plus cosine x. So that is the derivative of sine is cosine, and the derivative of cosine is minus sine. So there's a chain rule for us. So the best we can do is just rewrite this as a single fraction. Cosine x minus sine x all over sine x plus cos x multiplied by the natural log of 2. Okay, nice easy one to start with. Don't worry, they're going to get more complicated. Don't want to bore you. Make sure your parents are getting their maximum value for their educational tax dollars here. Okay, so this one looks really funny. I've got ln 2 as the base of an exponential function with an exponent of x. Well, if we just keep in mind that if I have y equals a to the power of x, its derivative y prime is just a to the power of x times the ln of a. Okay? So if we differentiate this, we're just going to follow that same form, except instead of having a to the power of x, it's just ln 2 to the power of x multiplied by the ln of 2. We can keep going, but we don't have to. That's as far as we go with that. So there's our derivative. Not pretty, but correct. Next. Okay. This is where we separate the men from the boys and the women from the girls. Differentiate this one. Whew, here we go. E to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x. This is a lot of fun. Let's get started. So we're going to have to use just about every rule in the book here, except for I think maybe the product rule. So let's go at this. From the numerator, remember we're using the quotient rule here all together, right? So if I have a over b and I differentiate, I've got to get a prime b minus b prime a all over b squared. All right? So let's see how we do with that here. So the first thing I want to get is the a prime, so the derivative of what's upstairs. I'm just writing this over here on the side. It's a little strategy I use because there's so many details with this. I don't want to forget anything. The worst thing is you get halfway through and you forget where you are. So now I know right now I'm just working on a prime. So the derivative of what's up top. So the derivative up there, e to the power of x is simple. It's just e to the power of x. Then I have to subtract the derivative of e to the power of negative x. Let me think about that one for a second. If I have to differentiate e to the power of negative x, that's just going to be e to the power of negative x times negative 1. So in other words, negative e to the power of negative x. Okay? So I have to subtract that, so I might as well say plus e to the power of negative x, because that's what's going to happen when I subtract the negative. Okay? So that's the derivative of the numerator here. So I've got that done. Now I have to multiply that by the original denominator, which is e to the power of x plus e to the power of negative x. Hey, it's the same thing again. All right. Then quotient rule says to subtract. And so now I have to differentiate the denominator. So let's see. The derivative of e to the power of x is e to the power of x. And we already said e to the power of negative x is negative e to the power of x. All right, so this is subtract e to the power of negative x. So I've differentiated the denominator, and now I have to multiply by that numerator again. So that's e to the power of x minus e to the power of negative x. Okay, so those are the four components I need for the numerator using quotient rule. Then I have to divide all of that by the square of the denominator. So the denominator here is e to the power of x plus e to the power of minus x, and squared. Okay, that's a bit scary looking. Lots of e's, but guess what else? We have to simplify it now. I know, that's awful, but no, it's not. It's not too bad. Let's see. So here I've got a binomial and a binomial. So let's multiply the first two terms. And e to the power of x plus x is e to the power of 2x when I multiply those. And then I'm going to multiply e to the power of x by the second term. So that's going to be plus e to the power of, now I'm going to add the exponents, so x plus negative x is 0. So it's e to the power of 0. And then I'm going to have another one just like that, because when I put these two terms together multiplying, I get e to the power of 0 again. And then I'm going to put these two together when I multiply, and I'm going to have e to the power of adding those exponents, negative 2x. Okay, so that's what I get when I multiply my first two binomials together. Now I have to subtract the product of the second two binomials that we had there. So e to the power of x times e to the power of x is going to be, better put a bracket there because we are subtracting here after all. So e to the power of x times e to the power of x is e to the power of x all squared, or e to the power of 2x. And then multiplying the first term here by the second term there, I get negative e to the power of 0. All right. Then I'm going to multiply these two terms and get negative e to the power of 0. And then the last two on each pair, I'm going to get positive e to the power of negative 2x when I add those exponents. And all of that, look at all those e's, all of that is still divided by e to the power of x plus e to the power of negative x all squared. Okay. Now let's see if we can simplify anything here. I'm going to get out my red cancellation pen because I got a feeling we're going to be able to send some stuff away. E to the power of 2x, and then when I subtract everything inside those brackets, that'll be a negative one of those, so that's gone. Okay, and this term is e to the power of negative 2x, and then when I subtract this one down here, that's gone. I think that's all I can get rid of right away, because if we look carefully for a second, anything to the power of 0 is a 1. So out here I've got 1 plus 1, which is a 2. And inside here I'm going to be subtracting a negative 2. So 2 subtract negative 2 is positive 4. And that's all divided by e to the power of x plus e to the power of negative x squared. Now we could expand that denominator if we wanted, but it's not really going to get any nicer for us. Just as well to keep that in factored, which is a simpler form, and we'll call that our derivative, dy over dx, or y prime. All right, that was a good one. A little bit of work to it, but that's okay. We're soldiering on here. Okay, let's try this one. So in this case, we've got to take the derivative of log of 2x squared. So it's a chain rule with 3 layers. So ogres are like onions. They have layers. So we got to peel off the layers one at a time. The outermost layer is the logarithm. So that becomes 1 over its argument, which is log of 2x squared, times the ln of its base, which was 10. Okay, then I'm going to multiply by the derivative of the next layer in, which is this bit. So that's 1 over its argument, which is 2x squared, times the ln of its base, which was also 10. Then I have to multiply by the derivative of the last layer in, which is 2x squared, so that becomes 4x. Okay, and this one doesn't look too bad to simplify. So when we go ahead and try to simplify this, we're going to have here, let's see, 2 and 4 is going to make a 2 up top, and x squared down bottom and x there, they're going to go away altogether. And let's see, I guess that's all we can get rid of directly, but we've got a couple of ln 10s floating around there, so they're going to be nice to put together and just call it ln 10 squared. So up top I've got a 2, and then down in my denominator I'm going to have let's see, log of 2x squared times ln 10 squared. You can, by the way, you don't see it as often as you do with trig functions, but if you have ln of x all squared, you can write that as ln squared of x. That's okay to do. It's weird, but it's okay. I don't usually do it because people get a little confused. And then our numerator we've already got, and that's all of our denominator. Oh, we're missing an x. I knew there was something I forgot, so there's an x there. And that's as far as we can go with all of that business. Okay, let's take a look at another one. Example 5. Who brought pie to the party? I was expecting cake. Just kidding. So dy over dx here is going to be, so this is an exponential with a base of pi. So it's going to be pi to the power of x minus 2 times the ln of the base, which is pi. So pi is a number like any other. Don't discriminate. Haha. And then when I take this part and I differentiate, that's just going to be 0, so I don't need it. And we're done. Wow, that was good. Nice, easy one after a couple of real tricky ones. We'll take it. Okay, a test type question, multiple choice. Now, I gave you this one with 6 options for multiple choice. Most of us are used to 4 options, but I assume many of you are going to be taking the calculus placement test. And from the sample that Memorial has given us, there are 6 options on many of those questions. So let's go for it and see what we come up with. So let's differentiate that. dy over dx is going to be equal. Okay, so this is a chain rule. Outermost layer is a cosine, then we've got an exponential, and then we've got a power function. So let's rock this stuff. So cosine becomes negative sine of the guts there, e to the power of x cubed, and then the derivative of e to the power of x cubed will be e to the power of x cubed multiplied by the derivative of x cubed, which is 3x squared. So we have to simplify that now. So I've got a negative, I'm just going to say 3x squared e to the power of x cubed times the sine of e to the power of x cubed. And does anything there match up with that? Well, I'm going to get rid of anything that doesn't start with a negative 3, first of all. So they're gone out of the way. So I've got 3 options to choose from. This one doesn't have enough stuff. And I think this one's got a cosine, which I don't need. So that's too much stuff. So it's got to be this one, B. Hey, we got it. Everything matches. Perfect. One more, I think. Let's see if we can tackle one more of these guys. Let's come up here. Differentiate y equals 2 to the power of log x minus log of 2 to the power of x. So let's keep in mind that both of these are just common logarithms. So there's log base 10. So let's see what we get now. dy over dx is going to be 2 to the power of stuff is going to be 2 to the power of stuff times log 2 when I differentiate it. Almost said log there instead of log. And then I have to multiply by the derivative of what's inside. So the derivative of log x is 1 over x ln 10. All right, and then we're on to the second term here. So I have to subtract the derivative of log of 2 to the power of x is going to be 1 over 2 to the power of x ln 10 multiplied by the derivative of 2 to the power of x, which is 2 to the power of x ln 2. Okay, so now can we do anything to combine things and simplify here? I'm going to get out my red pen for a second, see what we can throw away, because there's a couple of things for sure that we can destroy here, like this. Look, 2 to the power of x over 2 to the power of x is gone. That's great. Maybe, unless we needed it, we don't. Okay. So is there anything else we can combine or destroy? No. So let's just simplify each of those terms and then see if we can get a common denominator. So this will be, when I put it together, oh, I meant to go back to my black pen. Sorry about that. So we're going to have 2 to the power of log of x times the ln of 2 all over x ln 10. And then we have to subtract, the second part is just a ratio of 2 logarithms, ln 2 over ln 10. Which we could write as a single log if you want. That's just log base 10 of 2. So log 2, but I don't know if we have to do that as such. Well, we've got 2 of them. I guess we can do that. So let's say we've got 2 to the power of log x here. And that's going to be over x. And then I'm going to convert ln 2 over ln 10. That's just the same as log base 10 of 2, if you remember doing that. and then subtract log base 10 of 2 again. So common denominator of x, so we'll just do that, and then we can get it all together here. So putting all these things together, we're going to have, let's see, our dy over dx still. This one's a little more involved than it looked at first. So we've got 2 to the power of log x, log 2 minus x log 2 all over x, and then we've got a common factor of log 2. So we've got log 2 to come outside, not base 2, log base 10 of 2, and coming out of that, and then that's going to be multiplied by 2 to the power of log x minus x, and it's all over, same kind of bracket, all over x. There we go. That's a nice one. Cool. Very nice, neat, concise answer. We like that. Alrighty, let's see what's next. I'm betting we're getting close to the end here. It is the your turn question. Okay, so for the your turn question here, you have to differentiate a couple of different things. So take your time and have some fun. I'm going to move along to the solution, so if you want to pause, please do so. Work them out. Here is the solution for each of those. Wow, some of these are a little complicated, but not too bad. Certainly no crazier than the stuff we just did. So if you can handle that, you can handle just about anything that's a derivative of a whole bunch of different kinds of stuff combined together. Okay? Didn't put any trig in there. That's no big deal. I suppose we did lots of that before. So move along. Let's look at a summary of the key ideas here, and there's not really anything new under the sun. It's just combining old ideas. So let's recall the formulae for the derivatives of exponentials. There's your derivatives, and for logs, there's your derivatives. We've seen those lots of times. And the only thing I'm going to mention is it's important to practice. So you've all got textbooks and you've all got lots of things your teachers gave you, I'm sure. So practice the derivatives, check your answers. It's the best way to get better at it. So it's important to practice differentiation with these functions in conjunction with product, quotient, and chain rules. So I'm hoping that's helpful stuff. And I hope your studying is going really, really very well, and that you're all going to ace your exam. And good luck, and we'll see you in the next session if you're coming back. Thanks.